In the previous video, we looked at how we could write functions as power series. Why? Well, we're in calculus, so if we have a function, we should be able to take the derivative of it, and we should be able to integrate it. And that's what we're going to be doing in this section. Since we have a function that can be expressed as a polynomial, then we can do term-by-term differentiation and integration. That's exactly what a power series gives us. We have a function, term by term, it's really a polynomial, and therefore it's differentiable and continuous on our radius of convergence. That function, since it is differentiable and continuous, then our derivative would just be using the power rule. So if you took the derivative of the constant, it would be 0. If you took the derivative of this part, remember it's to the first power, so you'd multiply a1 times 1 and then reduce the power, and you get just a1, and so forth. You'd bring the 2 down in front, you bring the 3 down in front, and so our derivative can be expressed as this power series. Notice that our index has changed because our derivative has one less term, and that's because the derivative of our first constant was 0. Likewise, we can integrate using the power rule. So if we take this first term and add 1 to the power and divide by that, we would get this to the first power, and then so forth. The second one we would add and then divide by the 2. We would add and get 3. And so, because we are integrating, we would have that plus c, and we can get that power series. So now we are going to look at functions and express them as power series, using the idea that we may take the derivative or the integral to get there. So recall, a power series needs to be in the form of a times r to the nth power, and remember that sum is 1a over 1 minus r. So in the previous video, we made our functions become in that format, a over 1 minus r, and then we wrote it as a power series. Well, looking at this function, it doesn't look anything like that. So what can we do? Well, I want you to think. Does the derivative of the natural log, could it possibly look like that? Well, let's see. So if I take the derivative with respect to x of f of x, what would be the derivative of the natural log of 1 minus x? The 1 minus x would go on the bottom, and the derivative of that goes on top. Now look, that derivative matches that format. All right, so what if I took the integral of the derivative? If I take the integral of the derivative, don't I get back my function? And that's what I'm trying to do. So I'm going to integrate both sides. So this is going to give me my function. But remember, trying to get to a power series. So I'm going to integrate that, but before I do, I'm going to rewrite this as a power series. So looking at this, we can tell that a is negative 1 and r is equal to x. So my power series is going to be a times r to the nth power as n goes from 0 to infinity, and I am integrating that with respect to x. All right, so this is just a constant, so I'm going to pull that outside of the integral sign, outside of the sigma. And how do I integrate that? Fairly easily, just using the power rule. How do you integrate x to the n? It would be x to the n plus 1 divided by n plus 1 as n goes from 0 to infinity. But I do have to put my plus c. And what was my function? Remember f of x? That was the natural log of 1 minus x. So I've now written the natural log of 1 minus x as a power series, but I really need to solve for c. How could I do that? Well, I know that the natural log of 1 is equal to 0, so what if I let x equal to 0? So I'd have the natural log of 1 minus 0, and that would be the summation of 0 plus c. Let's solve that for c. The natural log of 1 is 0. This is 0. So what does that tell you that c equals to? 0. So now I know that my function is exactly that power series, the negative summation of x to the n plus 1 power over n plus 1, because I now know that c is equal to 0. Let's look at the second example. Again, this looks nothing like that. So you think, does the derivative of arctan look like that? Does the integral of arctan look like that? That's what you need to think about. So the derivative of my function, the derivative of arctan of x, is 1 over 1 plus x squared. And again, I think I can make it look like that. I could write this as 1 over 1 minus negative x squared. So if that is my derivative of my function, to get back to my function, I can integrate both sides. And so again, that would give me my function. And now I'm going to rewrite this part as a power series. A, which is 1, times r to the nth power. I might want to take out that constant, so I'm going to write this as negative 1 to the nth power, and then I would just have x to the 2n, because remember I can multiply that. Now I can integrate this with the power rule, so I keep my sigma, keep the negative 1, because remember I'm just integrating with respect to x, so using the power rule I would add 1 to my power and divide by my new power. And I need to put that constant of integration. And remember, that's what arctan of x equals to. Let's see if we can solve for c. I know if I let x equal to 0, the arctan of 0 is 0. So I would have, again, 0 raised to the 2n-less power. So I would get 0. That is equal to 0. And c again would be 0. Now be careful, that is not true in every case. It's nice when it is, but not true in every case. So arctan of x is equal to that power series. You actually can use that power series to get the value of pi. My challenge is to see how that would work out. Okay, so let's look at this function. Again, I'm trying to get it into the format of a over 1 minus r. With that squared, that's just not going to match. So what if I took the derivative like I did on the other problems? Okay, so remember that's 1 minus x to the negative 2. So the derivative would be negative 2 times 1 minus x to the negative 3 times the derivative of that. Does that help me? Actually, no, it makes it worse. So I didn't do anything wrong, but taking the derivative does not help me get it into that format. So since the derivative didn't work, let's think integral. So I'm going to integrate my function. So if I integrate f of x dx, I would integrate 1 minus x to the negative 2. So if u is 1 minus x, remember du is going to be negative 1. So I need a negative. So that is going to equal to, just using my power rule, I need a negative, and then I'd have 1 minus x to the negative 1 divided by the negative 1. So those would become positive. So this is 1 over 1 minus x plus c. And wow, that pretty much matches that exactly. But that's the integral. So I want to find f of x. So let's see if you can follow this. So our function is going to be the derivative of the integral. Remember, those are going to undo one of each other and comes back to the function. And I need to somehow end up in a power series. So this is going to be the derivative of my integral. Well, what was my integral? It was that. So the derivative of 1 over 1 minus x, and then the derivative of c is 0. How could I do that? Again, I need that as a power series. So I'm going to rewrite 1 over 1 minus x as a power series. A is 1, r is x, and I need to take the derivative. Now remember, initially this was from 0 to infinity. When I take the derivative, I have to be really careful. Okay, what's that power rule say? I bring the n down in front, keep x, and I subtract 1 from the n. So because of that, I need to now re-index that where n is equal 1 to infinity. Not too bad. My next question is what if we work those problems, but they had an x in front of them? As in, I said, f of x is x times this. Well, believe it or not, the only thing that you would do different is nothing, except that your answer would then be multiplied by x. Same thing here. So x times the natural log is equal to that. X times arctan is that. And same thing here. If this was x times this, then you could end up with this would be just multiplied by x. So just keep that in mind as you're doing some homework problems. Let's look at the last example. This is really why we do this, is integrals like this. This integral fits no known technique of integration that we've learned or that we will learn, except for using it as a series. How can we integrate that? Well, the cool thing is this right here can be written as a power series. 1 over 1 plus x to the 7th is 1 over 1 minus negative x to the 7th power. So that is going to be the series as n goes from 0 to infinity of 1 times negative x to the 7th to the n power. So if I have a power series, I should be able to integrate it. So I want to integrate negative x to the 7th to the n power with respect to x. And what makes that easy is because integrating with the power rule is just a piece of cake. So again, I'm just going to rewrite this by taking out that negative 1 and rewriting negative 1 to the n and then x to the 7n. So just integrating with respect to x, that's going to be keep my power series. Then I'm going to keep my negative 1 to the n, and then I'll have x to the 7n plus 1 divided by my new power. And now I would say plus c, but wait, this isn't plus c, this is a definite integral. So I need to evaluate this between 0 and 1. How do I do that? Just like I always do. So this is going to be, I'm going to put 1 in for x, and then I'm going to subtract when I put in 0 for x. So this is going to be 0. So my final answer will be negative 1, and then 1 is just 1 over 7n plus 1. That is what my original integral equals. So now I've taken an integral that I didn't know how to integrate, turned it into a power series. Not really that hard.